Alright, you guys, this is going to be your last section of notes for this year. Yay, that's a good thing. Also the last section of notes for this chapter. So we're going to talk about congruence and right triangles. And make sure you have the hypotenuse-leg theorem in your vocabulary packets. And I just want to first start off with how do you name the parts of right triangles. So obviously we have to have a right angle. And so we're going to make sure we have a right angle by denoting a box in the corner. So that's obviously a right triangle. And I'm going to label this triangle ABC. And these are the parts of a right triangle. The most important part you can possibly name is what we call the hypotenuse. And the hypotenuse is always across the right angle. And if you think about it, the right angle seems to have an arrow, and it's pointing towards the hypotenuse. And so this part right here, this is the hypotenuse. This is the side across the right angle. And it is also the longest side of the triangle. The other two parts are both called legs. If it's an isosceles right triangle, then the legs are obviously the same side, or you can have a short leg and a long leg. So this is what I would call the short leg, and this is what I would call the long leg. And in the case of an isosceles triangle, they're just simply called legs because they would be the same size. Alright, now just like all the other triangles, and when we were doing side, 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 angle, angle, side, angle, and angle, angle, side, we always needed three parts. Well, we're going to prove triangles congruent using HL, and even though you see only two letters, H standing for hypotenuse, L standing for leg, you still need to have three parts. You have to show you have a right triangle. So we're going to show this in a proof. And let's see what happened here. It says, one student wrote that triangle CPA is congruent to triangle MPA by side, angle, side for the diagram. Is the student correct? And remember, side, angle, side. In this triangle, the student can be correct because, don't forget, this is an isosceles triangle. And if you have perpendicular angles right here, then the converse of theorem 4.5 would tell you that this line has to be the angle bisector, which means this angle would have to equal this angle. And by reflexive property, this side has to equal this side. And so we clearly do have, we have a side, an angle, and another side marked. And we have a side, an angle, and another side mark. So the answer is yes. We can prove this congruent by side, angle, side. But you would have to have a few statements. So you would say yes by the converse of theorem 4.5. Angle CAP would have to be congruent to angle MAP. And by reflexive property, AP would have to be congruent to AP. It was given AC is congruent to AM. So triangle CPA can be proven congruent to triangle MPA by side, angle, side. By the way, what we just did is what we call a paragraph proof. Notice we did a proof not by using statements and reasons, but by simply writing it out in a paragraph. So this is called a paragraph proof. where you explain in a paragraph your statements and followed by reasons in a sentence form. Okay, let's do another one in our second example. Triangle XYZ is isosceles. From vertex X, a perpendicular is drawn to YZ, intersecting YZ at point M. Explain why triangle XMY is congruent to triangle XMZ. Okay, because we know this is an isosceles triangle theorem, or isosceles triangle, I can mark this side XM congruent to itself, reflexive property. Now, what I have is there's a number of reasons why these triangles could be proven congruent. We could use angle side, using, for example, angle Z, angle ZMX, and this side XM, matching the other parts on the other side. We could also, just like we did above, mark the other angles up here, the vertex angles, congruent. We could use angle side angle. We could also use side angle side. And we could also use side side side, because if this is indeed the bisector of the angle, then it would also bisect the base. So everything can be marked. What I wanted to do is show you how hypotenuse-leg works. Clearly we have two right triangles. So we can say triangle XMZ and triangle XMY are right triangles by definition of right triangles. Remember, a right triangle is a triangle with one right angle, and I can see my right angle. I can also know that XM is congruent to XM by the reflexive property. I don't know why I wrote property. By the way, XM is a leg of each of the right triangles. I can also see that it's given by the marks that XY is congruent to XZ. And these parts, just so you can see, are the hypotenuse of each triangle. So let's take a look at my three parts. I have right triangles, I have a leg, and I have a hypotenuse. So here's a new mark you guys can know. 3 dots in a row means therefore in mathematics. Triangle XMY must be congruent to triangle XMZ by the hypotenuse-leg theorem. And we're done explaining why. Now we're going to do a proof. And we've done, this is a paragraph proof. Now we're going to do a formal 2-column proof. Write a 2-column proof. Don't forget the very first statement is always what you're given. So I know angle ABC and angle DCB are right angles. I also know AC is congruent to DB. This is given to us. We're going to try to prove these triangles, and I'm just going to show you triangle ABC. Notice these are overlapping triangles. Here's triangle ABC. What kind of triangle is it? Well, because angle ABC is a right angle, this must be a right triangle. And the same with the other triangle. I'm going to highlight it in green. Triangle DCB. Here's DCB. comes up here. They said angle DCB is a right angle as well, so this is also a right triangle. So I know the green triangle and the blue triangle are both right triangles. So I'm going to make that a statement, because I need right triangles if I'm going to try to prove these congruent by hypotenuse-leg. So I need to say triangle ABC and triangle DCB are right triangles. And what do I know? Definition of right triangle. This is how I know this. Okay, now I needed this. This is one part that I needed. The other part that I need to know is that they said AC is congruent to DB. And if I take a look in the blue triangle, AC is the hypotenuse. And if I take a look in the green triangle, DB is the hypotenuse. So I have the right triangles and I have the hypotenuse. I just need the extra leg that's congruent. And you can clearly see they have what we call the common side. I can mark this congruent, and I need to just state it in my statements. So I can say that segment CB is congruent to segment CB, and the reason is reflexive property. This is the third congruence piece that the third piece that I need to say that my triangles are congruent. So I now know triangle ABC is congruent to triangles DCB, and the reason is because of the HL theorem. Okay, so don't forget, you need three parts. You have to have right triangles, you have to have the hypotenuse. This is my hypotenuse, this is my leg, and I know I have right triangles. Let's just see how you guys are understanding this by doing a couple of problems. And for exercises 1 and 2, tell whether the HL theorem can be used to prove the two triangles are congruent. If so, explain. If not, write not possible. I can mark my common side for the very first one. BC is congruent to itself reflexive. I definitely can see my two right angles, which means I do have right triangles. AC is the hypotenuse. DC is the hypotenuse. And this common side is the leg. So the answer is yes. Triangle ABC for sure is congruent to triangle DBC by hypotenuse leg. Okay, I definitely have two right triangles. It says, tell whether the HL theorem can be used. In this problem, I cannot use the HL theorem. I could use side angle side, but I cannot use the HL theorem because the hypotenuse is not marked, and I cannot mark it. So HL theorem cannot be used because the hypotenuse is not marked. But side angle side could be used. Okay, let's finish with exercises 3 and 4. The directions say, what additional information do you need to prove the triangles are congruent by the HL theorem? So let me clear this ink and move it up. And these will be our last two examples, and you guys can work on your assignments. Okay, I want to prove triangle LMX. I'm going to highlight LMX. I could definitely have a right angle right here. Congruent to triangle LOX. I'm going to highlight triangle LOX. I definitely have a right angle here. How would I prove these triangles congruent? Now what I know is I got a common side right here at LX. LX would have to be congruent to LX, and it is by reflexive property. I can mark that. But what else would I have to know? I would need to know about the hypotenuses in each of these triangles, otherwise known as hypotenuse. So I need to know the hypotenuse in each triangle is congruent. Or I need to know LO is congruent to LM. That's what I would need to know. Okay, what about number 4? Triangle AMD. AMD obviously is a right triangle. I know that. And I also know the hypotenuse is marked. Now take a look at that compared to triangle C and B. Again, it's definitely a right triangle with the hypotenuse marked. I would need to know a leg is congruent. Does it matter which leg? No, it does not. But I would need to know a leg is congruent. So either AM would have to be congruent to CN, or the other leg, DM, would have to be congruent to BN. It would not make a difference as long as one or the other is marked. That's what I would need to know. Alright, you guys, it's a very short assignment today. There's only 6 problems, and I will see you in class. You have a great day.